Okay, my name is Aubrey Farmer. I'm going to be talking about the difference in the antagonist activation with the heavy bench press and the ballistic bench throw on the Smith machine.
And I'm Paige Biaggi, and I'm comparing and contrasting muscle spindle and Golgi tendon organ.
Okay, so first we're going to start off with the heavy bench press. So it's going to be a slow and controlled movement. Your primary movers are going to be your agonists, and those are going to be your pectoralis major, your triceps, and then your anterior deltoids. And then what those are going to do, those are going to be a controlled movement since the bar isn't set on a machine. It's just going to be, you have to slow it down, and you're going to be activating all your muscles. So antagonists included on the downward movement, which is going to be the biceps, the shoulder extensors, and then posterior deltoids.
What's the difference between agonist and antagonist?
So the agonist is going to be the primary muscle, which is one that's going to be used the most, and then the antagonist is going to be the resisted force against that mover. And then for the ballistic bench throw on the Smith machine, you're using all that force to push the bar up, that when you're bringing it back down in the downward phase, you're not using the antagonist as much. They're not really activating because you're kind of using the momentum to go right into the next bench throw because you're trying to use all of your force to push it. And with it going down, you're bringing that back up and pushing it again. So it's not activating as much up in these areas as it is when it's being thrown up.
So is the only difference like the speed?
It would be more of like the force produced. So with the heavy bench press, you're lifting heavier. So you're going to need a slow, controlled movement, which is going to be causing each muscle to activate as you're slowly going through each one. And then with the ballistic, you're going to be using all of that force in the agonist to throw it forward or up, and then using that to kind of stabilize it, but it is a set form, so you're kind of bringing it down and then using that momentum to push it back up, and it's just going to be the same thing since it's a lightweight.
Okay.
And before I forget, O-line for football, like the offensive line, they're going to be using more of the ballistic bench presses as they need to push through the defensive line to get to the quarterback before he can throw it, which is 10 seconds at most, maybe. And then for the defensive line, they're going to be more of the heavy bench throws as they want to set the line, and they can't let anybody pass them, so they're using their strength to hold it down.
Gotcha. Good explanation. Okay, so for muscle spindles, they're sensory organs. So they're in a little capsule with intrafusal fibers and actin and myosin, and they're parallel to the extrafusal fibers, which are just like the skeletal muscles. So when it extends, like when you rapidly lengthen the muscle, the muscle spindle sends a signal to the spinal cord, which sends it to the main muscle to say contract. That way you're not like extending, and then like you injure yourself by tearing it or pulling a muscle.
Right.
So then that contracts, and then when you're like in something, we'll say like sprinting, that's actually necessary because that creates the tension. So when you extend like the quad in an eccentric contraction and plant the foot, that activates the muscle and it's saying contract, and that gives it the tension that when you push off and you have a rapid concentric contraction like immediately after, you have more force being pushed off into to like propel you forward.
Right. And what's like the actin and myosin?
Actin and myosin make up the muscle fibers, which make up the muscle. and then the actin and myosin are proteins that contract, that are like the contracting parts.
Right.
So when the muscle, when the signal goes back to the muscle and it says contract, it's the actin and myosin. They're like pulling on each other.
Okay.
And then Golgi tendon organs, they're the exact opposite. They tell them to relax. So when you're in like a bicep curl and you're contracting, and like there's a heavy weight here, if you contract too much, you can injure yourself. So the Golgi tendon organs, they're in between the muscle and the tendon, and when you activate the muscle, it'll like compress and deform the GTO. And if it's activated too much and then the GTO is like deformed too much, it sends the signal to the spinal cord, sending it back to the muscle saying relax. And then generally that means you'll probably fail that rep, but that's probably good, because if you're like contracting, and then it says relax, it probably means your muscle would injure yourself if you go too far.
Right, so what's like the biggest difference when it comes to the spindles versus Golgi tendon organs?
The biggest difference is the signal they're sending. So the muscle spindles send the signal telling the muscle to activate, and the Golgi tendons send the signal to the spinal cord and telling them to deactivate.
Right. Okay.
Good job, Aubrey. Did we get an A?